Kokotsakis flexible meshes with skew faces, generalization of the orthodiagonal involutive type. Studying mechanisms and kinematic systems is interesting in mechanical engineering, leading to intricate mechanical systems design. There, mechanisms usually perform their magic deep inside machines, hidden from our view. Architects, designers, and artists use mechanisms differently, putting them on full display to solve complex design problems. This allows their creations to transform and adapt to the current use case or environmental changes. Unfortunately, the repertoire of mechanisms used is quite limited. This is caused by a lack of accessible design tools for complex mechanisms and the fact that few systems can be scaled to an architectural scale at a reasonable cost and effort. In the past, we investigated several new systems and their application in design. Among others, the isometric deformation of surfaces or complex invertible 5-bar linkages. We introduce an exciting generalization of the flexible Kokotsakis polyhedron, the orthodiagonal involute type with skew faces. Skew quadrilaterals significantly increase the design space and the possible expressiveness of designs. The main difficulty in constructing such an object is performing exhaustive symbolic and computational calculations. However, focusing on a specific type can help significantly and simplify the design process. Once the precise geometry is found, the mechanism is easy to realize, even at large scales. The rotational joints are easy to realize in practice. We are sure the design community will explore the ample design space and find new and exciting uses for this new class of mechanisms. We evaluated our design tool and the practicality of these new skew quad mechanisms by selecting a very extreme example from the design space with a 90 degrees skew central quad. We built a small-scale physical model of this mechanism. The shown model is about 180 mm wide. The model moves precisely as expected and demonstrates the expected range of motion. To ensure that the exhibited flexibility is solely the result of its geometry and not caused by some elastic deformation or play in the joints, we built our model with tight tolerances from stainless steel. The quads are made from 0.8 mm cold-rolled laser-cut stainless steel sheets. We ground a V-groove along a diagonal of each piece and created the skew quad by bending along this diagonal and welding in a bracing element to stabilize the quad. Small stainless steel capillary tubes were cut and welded to the edges of the quads while various jigs ensured the correct alignment of the pieces. During assembly, hardened steel pins were inserted into the joint knuckles. All tolerances are so tight that these pins are just held in place by friction, yet the whole mechanism can be moved easily and smoothly. The prototype clearly shows the expected one-parametric motion. This is demonstrated in these stop-motion videos. On the left side, you can see photos of the prototype. The image on the right side shows a rendering of the digital model.